Welcome, everybody, to the American Space Museum. I'm Mark Marquette. We're so glad you're with us today to stay curious. Another special show with Gary Allgire beside me. Hi, Gary.
Hi, yeah, Mark.
Gary was a structural engineer, spent over 3 decades working on first Apollo and then the wonderful era of the space shuttle. And he talked about Apollo 1 earlier this week. That is on our YouTube channel. You can see them. And today, Gary, you're going to share with us what you learned and have investigated with your curiosity 38 years ago of the Challenger disaster.
Yeah.
Welcome, Gary.
Thank you very much. I actually did a little bit of work there. I was in the firing room the first time we tried to launch, and then I was there also for the second launch. So I'll talk about that here.
Good, good. Yeah, we got a program here. We're lining stuff up here with Marty Winkle, our co-producer. We've done 976 shows, counting
Wow,
this one
amazing.
today. And of course, Marty was there and witnessed the Challenger tragedy. And something I've heard from all the space workers here in my 6 years around this museum is everybody that lived here remembers going out and watching it and the split contrails and we've Marty and I have always decided to take the high road and celebrate the lives of these wonderful astronauts. And this year, with Gary's help, we're looking at more of the technical side of it. Yesterday, we had Terry White talk about the recovery of Columbia, and Terry also revealing things years later that you don't think about, or hard to write about Challenger and not, everybody's just wrote about it and their own opinions and so forth. Yeah. But Gary's is a little bit unique because he was there. He knows some of the players involved, and we put together a good show for you to share today. Okay. Take it away, sir.
Okay, the first time that we had noticed a seal problem was STS-2, and then again on STS-6 we had noticed some seal problems. They were seeing some little bit of a blow-by of the two seals on there. NASA was concerned. However, there was, due to the environment, the political environment, it was decided that NASA, instead of shutting the program down for 2 years to fix the problem, is that they would manage the seal issues. And that would be under the responsibility of Marshall Space Flight Center, because they were the design agency for the solid rocket motors and the external tank.
We want to give a little side note before you get into too much of the details here that you and I were looking up here. There's our beautiful crew, celebrated around the world but around America, in schools, buildings, streets, you name it, named after these brave explorers. We have to say who they are. Michael Smith there, rookie pilot. You've got Dick Scobie, who flew one mission before this one. Ron McNair also had a flight to space. On the front row behind is Judy Resnick, who one trip to space. There you got Gregory Jarvis, was a space, an astronaut, company astronaut, taking a payload up. Of course, Elson Onizuka on the left-hand side, and Krista McAuliffe, the teacher in space. And why this got so much notoriety was she was technically the first citizen to go to space and was going to teach a lesson to kids. And everybody said Krista was born to play this role. 25 launches into the shuttle. Look at them. They've just got coveralls on, some go-kart helmets, not really much protection there. And then, of course, that all changed when we, as was it Bob Crippen or one of the astronauts, I think Hoot Gibson actually said it, that this was the day NASA lost their innocence.
That's true.
One other side note there, to just love the fact that this is such a significant and easily visible emblem for the 51L. And we just found out that Ernie Rios, a friend of the museum, here's Ernie in later life, but a friend of yours. Ernie passed away in 2021. He was very active with sharing our museum. Like you said, he was active in promoting NASA as a tour guide.
And he was, yeah. He was very, very popular, and he was very, a lot of people wanted him to give the tours. He was very funny. He had a lot of good stories to tell, and he kept you entertained. And I tell you, when he came into our office, he lit up the
Huh.
office. He was just a welcome visitor to come in, and we would tell him what he needed to know so he could pass it on to his guest.
Those of you out there familiar with the uh, Snoopy logs, that the little Snoopy character that was written on the daily briefs of all the
The daily schedules.
the schedules, he did that. He was the person that wrote them on that. Marty,
It's called Kicks.
the
Kick-
Kicks.
Yeah.
Kicks. KICKS.
Okay.
Yeah.
That's what acronym for your schedules coming out there, and those sell for $100 all day long of the Apollo era when you can bundle them up together. But did not know that Ernie was responsible for this mission logo, that the Challenger is soaring from Florida, going into space on a variety of goals. You have 5 astronauts and 2 payload specialists represented by the stars on the flag. They were going to observe Halley's Comet. Was a big deal that they were doing. You see Halley's Comet streaking across the American flag there in silver, and you have the surnames of all of them around there, and of course the apple is the symbolic of the first teacher in space. So without further interruption, except to say what a gorgeous photo you brought in and Marty chose to use for our background here. You said, that's not a photo often seen. Looks like from top of the VAB.
It is, and that's Challenger going out for its final mission to the pad, and it's on the MLP, on the gravel roads that lead to the pad.
Mm-hmm. What are those buildings around there?
Those are, they're support facilities. They have some. It looks like a nitrogen tank there that they would use for supply to the pad. You have other stuff is just support there. I really don't know because we never had any business to be in those buildings,
Okay.
and so we just kind of knew they were there.
All right. Well, I didn't know what they were.
Yeah.
Hoping you'd say, see that window far over there to the left? That's my window there. But
No, we were in the O&C buildings for a long time, and then when we finally moved out for shuttle, they put us in first in the VAB.
okay.
That lasted for a few years, and then they finally built us an engineering complex across the street from this place right here. What you see now, temporary buildings that lasted longer than they should have, and then eventually they did build us a nice engineering building for us to stay in.
Well, Gary, proceed with your introspective of the 51L Challenger
Like
disaster.
I said, NASA was going to manage that. Now, I don't know exactly the criteria, but they were trying to manage it. Now, 51C, which was a DoD mission on Discovery,
Okay, go ahead.
was the first time that they actually had launched when the outside temperature was 53 degrees, and that kind of became a baseline cycle.
Floridians think it's cold at 53 degrees.
53
They really
degrees,
do.
yeah. So, but it was the coldest, and then follow up on April the 29th of 1985, STS 51B experienced the worst case of blow-by and degradation of the seals, but there was no penetration into the metal and no blowout of the metal. But that was the worst case up until Challenger. And then STS 41C, that's when back in 1983, they had one of the problems is Thricol never considered the seals as a Class 1 issue, which Class 1 is. It means that if it failed, you could do the loss of the crew or the shuttle. And so it was not until that 83 that they actually categorized it that way. But they also didn't categorize the manufacturing of the O-rings as a critical item. And Thricol did not get to know what the material was made of and how they made it, because the contractor, when they developed the formula for those seals, they made it proprietary. And so nobody could have that information. And they could change that formula on a will, and NASA would not know about it.
My gosh.
Yeah.
He's going to talk a lot about O-rings. I wanted to clear that up for everybody that doesn't really know. O is the circle.
Mhm.
You ever taken a flashlight apart to put a battery in and that little rubber ring falls out? That is a O-ring seal to seal moisture
Yeah.
from out of the battery. So that's a simplified version of what the O-ring seals are to keep this hot gases from the solid rockets that burn. Those are hollow inside, folks, and they burn from inside out incredibly. Not
Yeah.
They're not stuffed like a pop bottle rocket, and they
No.
burn up. They burn inside out, and it's actually contoured for different thrusts at different times.
Right. They vary the wall thickness based on the thrust, so it matches when they do the throttle down and throttle back up. So when they go through the max Q, they can do that. So it's a very unique system. And then after each launch, they could send them back to Utah where they're repacked.
Yeah, and they would fly them again, but I've noticed never the same stack of 4.
Okay.
They didn't matter. They jumble them up from mission to
Well,
mission.
they tried to match them. If there's one that has an issue, and they took it out of the deal, and there was another one that was assigned, it was cast at the same time, then they would put that in, and so they would always have a match pair.
Okay.
They didn't want to have one that was maybe had a little bit more performance than normal.
Mm-hmm.
Okay. Now the issues we're going to come up to is 51L, which is the Challenger accident. Now the engineers at Thical noticed that through an article in, I think, the Orlando Sentinel, that they were predicting the air temperatures to be in the low teens the day of the launch, and our possibility of that. So there was a lot of discussion internally to their management and also with the Marshall management, and a lot of argument about that. And it got to the point where there was a 3-hour telecon conference, and they got to the end, and one of the NASA managers said, because the engineers were very, very concerned with those temperatures, they were asked, can you prove that it will fail? And they said, we cannot prove it will fail. So it changed kind of the way the argument would go. And finally someone said, you mean I have to wait till April to launch because of these cold temperatures? And that was it. And they never were allowed to report the findings that the engineers had to NASA management above that chain.
Well, they found out January 28th,
Yeah.
1986. Let's move forward here with
Okay.
there you go.
Now, this is again a picture of the Challenger out at the pad. Again, they saw temperatures that actually dropped down to, I think, 18 degrees that night.
Yeah, we'll see some pictures later on about that.
Yeah. And the projection was at the time of launch, it would be 26 degrees.
Tell us, what was the payload? What was
payload-
a beautiful when they did launch it
Yes.
about 11 in the morning?
Payloads was the major payload was an IUS Tidris B. Challenger, this is the IUS Tidris A, which was the first one we launched, and this is actually Challenger. It was the first time it launched, and it carried the IUS Tidris up into orbit. It didn't fare well. It had a thruster that was stuck, or actuator stuck, and it actually flew in circles, and it flew through its own exhaust. And we finally made it on station, but it was going to be used as a reserve satellite, communication satellite. So Challenger, the second time we launched it, the B version was the replacement for the A. And then above that, they had, this shows it being deployed on the first mission.
Mm-hmm.
Above the IUS Tidris, we also had a pallet that was going to be deployed.
That was STS-6 in 83.
In
The
83.
Challenger's maiden flight that we're looking at here.
Yeah. And it had an deployable satellite that they would send out, and then they would retrieve it and bring it back if they had made it into orbit. As well as that, they had the 7 crew members. And this is a picture of the TDRS after it's deployed in a geosync orbit. And you'll see the antennas. The blue stuff is the solar panels. Then you have your two dishes out, and you have a small white dish, and then you have some horns in the middle that are used for different channels and different communication levels. This rectangular thing that you see there, it looks just like a Starlink antenna, but it's not. What it is a sail.
Yeah.
They had to counter-react the other white antenna that you see there, because
Yes.
the sun reflecting off of that would actually cause the spacecraft to rotate out of the plane.
Oh.
And so to counteract that, they had to put a sail on the other side. So all the TDRSs had this, that they finally launched in the program.
Couple big ears up there in space.
Well, our communications, and it really was something that was very important. That gave us the capability to almost have 360 degree coverage from the space to Earth. There's the higher inclinations due to the curvature of the Earth. You lost communications for it, but they do communications between satellites and the ground. This was a very, very important program. It takes three to make a system, and I don't know what they're using today. Those probably have all been used up and they're not active anymore. But I'm not sure about that. But that's what the TDRS would look like.
We'll look into that. I think some of the TDRSs are still active in there. They had some backups, but maybe someone will comment there as you're enjoying this conversation with Gary Allgire, talking about the Challenger accident. We're going to look at the crew and their positions of the crew here. What happened to that one before there? You had that. Yeah, you had that one ahead of that one picture.
We had an extra payload that was in the mid deck, and that's just to the right there. Where you see a single chair by itself.
Yep.
And that was called a Cephas.
See the picture of that in a minute. Let's look at, there's the up at the flight deck, and then there's how they were arranged. If you didn't know, 4 top. The next, if there's 5, one person's by himself in the mid deck, but that looked like this in a dress rehearsal. Because I said, Gary, is that on the pad? Well,
I pointed out it is not, because they're standing.
That's Barbara Morgan in the back reading some technical notes or something. So it had to be in Houston. Krista McAuliffe is sitting there. Gregory Jarvis, and in the back is Ron McNair.
Yeah. And he's sitting in
right above my head is the thing you're talking about, Gary.
No, it's to the right here. Let me see.
Yeah, above my head.
Right here. This is a Cephas right here. And what this is an experiment which actually was built by McDonnell Aircraft Corporation, and it was an actual furnace. And what they were planning to do is take different metals, heat them up, melt them, and combine them to see how that reacted in zero-G environment for future possibility of manufacturing components in space. And it was a heavy, it weighed about 200-something pounds. So it was equivalent to having 8 astronauts. So when Challenger launched on this mission, at the time, it was the heaviest shuttle launch we'd ever had.
Very interesting. Let's give them a little more detail, Gary, as we look at this somewhat familiar picture. Marty may need to have the arrow there. You've got McNair is right near the hatch.
It's hatch. Now that is a unique position for the first several shuttle missions. Later on, what required that position to be there is behind the 2 astronauts the closest to us. That is the airlock.
Beside Barbara Morgan standing up there. That's the airlock to go into the payload bay. All right, the whole white structure back there.
Now the airlock was designed to be removed and taken out this big back door. They would take it off. They would flip it around and they would bolt it to the aft bulkhead of the crew compartment, and that gave them a lot more volume in the mid deck. And when they did that, the astronauts did not. The ones you see sitting by the hatch in the window, it was moved away from there, and he sat in behind him, the other 2. Yeah.
So they built I guess it'd be Discovery, and the others with the exit on the in the side the payload bay, and not in the give you more room back in there for more stuff.
And behind his helmet, Jarvis is sitting on the by the hatch.
Uh-huh.
Right behind him is the bathroom.
Okay.
If people want to know where it was at, you'd come in through the hatch, you crawl in, and immediately to your right would have been the bathroom.
Okay. I see a ladder on the right
There's
too.
2 ladders. There's one on each side of the vehicle,
Uh-huh.
and there's an opening in the flight deck.
So that's how you got up there.
And now in 0G, you don't need the ladder, but when they land, they do need the ladder to come down off of the flight deck into the mid deck to exit the spacecraft.
Very interesting perspective of the.
So they always flew on the shuttles.
That's right. We go back to this. You get in a little out of sequence, but there's practicing. You got the astronauts there. You got Smith on the left. You got Scobie on the right, and Judy Resnick's in the middle. With beside her is Al Onizuka, there in the Columbia, ready to go for her 10th flight.
And Ellison, this is his 2nd flight.
Yes, it is. He was on a
in the
DoD
back-
mission.
Yeah, in the back you'll see the 2 windows that they would look into the payload bay with, and that station is where they would control the arm. And the arm was also installed on Challenger for this mission. Now the 2 astronauts that are up there,
Mm-hmm.
on re-entry, they would move down below, and they would be replaced by 2 of the astronauts of the 3 that were sitting in the mid deck and come up. So
Mm-hmm.
all but one got to at least see through some windows during launch or landing.
And they're important to feeding data and checks of checking this and that as they ascent or descent on there, helping the pilot and the commander. All right. So
And you can see that,
yeah.
go back, you can see
Yeah.
the airlock inside the
Yeah,
crew
now that
compartment. And then you have the Cephas right there by that door hatch.
by that
inside.
one chair by
Yeah, in
itself.
front of them, there would be lockers for have all their food, clothing that they would use on the mission, and then they would have basically they would have duffel bags, or not duffel bags, but sleeping bags that they could crawl into, and they could sleep on while they're in orbit. Some of them just floated around. Story Musgrave was noted for just floating around and bumping into people. when he
I
would
could
go to
see that
sleep.
with Story
Yeah,
for
yeah,
sure.
That's for sure.
Bless his heart. But good perspective of what it'd be like in there. And then those chairs folded up, right?
Yes, they did.
Stowed
They
away
stowed away. They had storage compartments in the floor too. I don't know if that's where they were put, but they did stow those seats away.
Mm-hmm. Well, here's the scrubs you talked about.
Yeah.
So actually, they tried to launch beginning January 22nd. Now, just landing. Let me see what date that was as I consult my shuttle scroll here.
Well, they were
61C landed on the 18th of January.
Well, you see, that was delayed because they wanted to bring 61C down and land it at Kennedy. However, all the landing sites at the time when they wanted to come in were had issues. They were either had cloud cover issues, wind cover issues, so they kept delaying it, and this pushed the schedule of 51L out a little ways. And the same thing on the 23rd, they couldn't land again, and then I think on the 24th they scrubbed. I think the 61C landed on the 23rd, but it landed at Edwards Air Force Base.
Correct. Yes, Bill
Okay.
Nelson was on that,
Okay.
hoping to get Florida oranges. Instead, they gave him a crate
Yeah.
of California grapefruit.
Yeah. Now they could have launched on the 23rd, but the problem was they had to scrub because that's still delayed because of the landing. The 24th they could have launched. The weather was good, but unfortunately the transatlantic abort site was had huge crosswinds, so they delayed the launch again.
Over in Gambia or Senegal or
Senegal, I think was the one that was
okay.
going to land at. And then on the 25th, we were going to launch, and there was launch preparations delays, and then finally the 27th was when we were going to launch. And that's when I was assigned as a project engineer. I was assigned to work third shift that evening in the firing room at our console. I had myself, and then I had a Rockwell project engineer next to me, and everything went smooth. The crew was inserted into the shuttle, and then as my relief came in to relieve me at the end of the shift, which was close to when they were going to get ready to close the hatch and then launch. I had never ever in my life, as in a career at NASA, never had participated in the firing room during launch. I was always outside watching because I just didn't have any electrons or fluids to worry about.
Right.
So
Structural engineer
so
guy.
I asked my the relief. I said, "Was it be okay?" I told him, I said, "I've never done this, and I would like to just go through one launch in the firing room and see how it works and what the atmosphere was like." And he says I could stay there, and I said, I'll be out of the way because I'm officially been relieved. I was plugged in so I could listen to what was going on. They closed the hatch, and when they close the hatch, they have to do a pressure leak check of the seals around the hatch. And to do that, they have to remove a thermal plug that exposes the port they stick a probe into. They will pressurize that between the two seals, and they'll have a spec that says it has to have a leak rate less than this over a certain period of time. And if it passes, then we're good to go. So we know we have a sealed hatch. When they took the probe out and they went to go ahead and install the plug back in, it was a single machine screw that they had put in. It galled it. Now, galling is caused, and we had this many, many times in the Apollo program. We used stainless steel fasteners with stainless steel nuts. If you put those two together and put them under pressure, the molecules between the atoms on the two materials will cross over to each other and form a single piece of metal, and that's called galling. Okay. Now, to preclude that from happening, what we always did, is the nuts were silver plated. The threads were silver plated, so we had dissimilar metals, and they didn't have the galling issues. But over time of taking the screw in and out, it would wear the silver plating off, and that's when we would get galling again. So normally they're held in by a nut plate, which is and it's two rivets that's riveted in, and the nut plate is captures the nuts. It kind of floats a little bit, so when we put the screw in, it'll go into that threaded nut because they don't have access to it. So that's what galled it up, and so they called for a battery operated drill to come out and drill it. Rockwell at the time sometimes doesn't plan enough. They did not have one in the white room or in the toolbox right outside, so they called for one. And when they did that, I had this premonition based on, it was a strong one, based on my experience working through Apollo and early shuttle. I said, that drill is going to be almost depleted. The battery will be almost dead, if not dead. And when I thought that, I said, I know it's what's going to happen. So I looked down at my relief, and I told him, I said, tell them to bring 2 drills. I said, that drill is going to have a problem. And he didn't do anything. So I told him again. I said, would you please tell him to bring 2? Well, he didn't do that either. So they brought the drill up. It took about a half hour, 45 minutes to bring it up to the pad. And when they got it up there, sure enough, when they started to drill, it ran about 2 seconds and it died.
Wow.
And I was so upset about it because I said, I know it was going to do that. I don't know why, but that's what I thought. They then discussed whether to go get another drill. And they were figuring out, well, it's going to be another 45 minutes or an hour to get another drill. I don't know where they got the first one, whether they picked it off somebody was working on one and they just grabbed it, or it was in a bonded area or not. But let's see, I'm losing my train of thought here. The drill, they were going to get the drill. The problem was that they had an LCC requirement, launch commit criteria, that the astronauts, once they in their couches on their back, they can only stay there for 4 hours.
Mm-hmm.
And to go get that drill and come back up and fix it, it would have exceeded the 4 hours.
Hmm.
So they decided to scrub. Now, in the meantime, also the winds at the landing site at the Cape were picking up, and that probably would have scrubbed it also. So they scrubbed it. So I went home. I was scheduled again to come back in on second shift that night for the launch. So the temperatures were dropping. I came in, sat and relieved my first shift individual, sat down, and there's really not much going on that night. The only thing we were getting reports was from the captain of the two recovery boats that were out in the ocean waiting for the launch. And he kept calling in saying, the winds get picking up, the temperatures are dropping, but we're okay. Now they're on these boats, the Liberty Star and Freedom
Mm-hmm.
are flat bottom boats. They're not ocean going boats. Ocean going boats have a V hull in them so they don't get slapped around. And the reason we have flat bottom boats is they have to go up the Banana River to drop off the SRBs when they retrieve them. And it's a very shallow, so they have flat bottom boats. Eventually, the winds started picking up, and the seas got rougher and rougher. The temperatures got dropping. And then in the meantime, I had asked my Rockwell project engineer, I says, why are we launching tonight? And he says, well, the mission management meeting at night had decided that if they could make it through tanking tests, they would launch. And so that was what was put out to the launch team. In the meantime, the captain finally at about 11:30 came on board and said, it is so rough and too dangerous, we are coming back in. And I thought, well, we're not going to launch,
Mm-hmm.
because there's nobody out there to retrieve them. So I went home, slept, came back in, and lo and behold, they're getting ready to launch. And I said, how can we launch? We don't have the boats out there. And he says, well, we don't need them. What we'll do is they have signal buoys on them, and we will send out a marine advisory that if you don't go into that area, and when the seas calm down, we will go out and retrieve them.
Hmm.
So they made a
Wow.
decision to launch. At the time of the launch, I think it was 26 degrees.
Look at those
temperature.
icicles.
They had icicles because during the night they were concerned about the water lines at the pad, so they cracked open the valves to let the water drain. Unfortunately, the drainage system that was at the pad got overwhelmed, and the water just ran out. And I think there's another picture here showing the icicles. They sent out they sent out an ice team, and the ice team reported that they had icicles. They would knock the icicles off the railings, but the real concern was that the deck where the astronauts come out, if there's a problem or they have to emergency get out and go use the buckets that they would slide down a slide wire to a safe area, that floor was covered in ice. And the ice team recommended not to launch to the launch director based on that. It's not until that ice melts would they approve the launch. Also, there was concern about ice impacting the shuttle tiles, and the ice team says we cannot tell you whether it's going to impact or not. NASA contacted back at the factory and talked to Patron. He analyzed it, and he said, I cannot give you an okay to launch because I don't know what the ice is going to do. NASA was looking for a confirmation that, the ice will not hit the shuttle, but nobody could confirm that. So they continued on even though that they were told twice not to launch because of the ice issues.
Mm-hmm.
So anyway, they ended up Unfortunately, they launched, and you know the results of it was.
Yes, we do. Even delaying it from 9 o'clock to 11 o'clock.
They did
still.
that to help soften up the ice.
Really,
Yes,
Huh.
and
but it's
they
still too cold.
it was too cold, and
You're going to explain. Go ahead, sir. Well,
The-
next
the-
slide, we're going to talk about those SRBs.
it's been theorized that the O-ring seals during the night uh, ended up getting, basically they calculated that they would have been exposed to 8 degrees Fahrenheit. And Thykol says 53 degrees was actually the lowest
Wow.
that he should launch at. Let me see what the actual temperature was. The reason why they theorized the seals got so cold. Now we're talking about the seals. There's 4 solid rocket segments that you see up there. The one with the nozzle is a nozzle segment, and also it's also has a propellant in it. And the seals that we're going to be talking about is between the nozzle system there and the first segment that you see. That's just.
I'm going to get our model over here, Gary, that we used the other day. That's got about a dozen astronaut signatures on it there. So you can point out there what.
Well, we got to turn it around.
Uh-huh.
Let's go to the right side.
Okay.
Okay. And what we're talking about is this area right here. This is a segment. This is the first segment. This would be the second segment. This is a third and a fourth. We have some instrumentation up here, and up here under the nose cap and the fairing is the parachutes that they deploy for coming back and landing. The seal that we're talking about is right in here, and we'll have a cross section that we'll show later that shows the 2 seals. There's a primary seal and a secondary seal, and this is also where they attach to the external tank is right here. It's not quite shown here right now. Now, this is the hydrogen side. The hydrogen, let me look to see what that temperature was. It's 400.
Talking with Gary Allgire here. Get you a
Yeah,
drink
let
of
me-
good water
let me,
there. You're doing a
let me
great
see-
job. We're
let
talking
me
about
see
the
if I can-
Challenger
I thought I had it written down here.
accident 38 years ago. There's been some memorials around town.
Yeah.
The mirror ceremony, I believe, was today, and we roll into this on January 25th, 2024, into what's called NASA's darkest week, starting with the 27th is the Apollo 1 fire that Gary talked about this week so expertly, and of course Challengers on the 28th, and February 1st, 2003 is Columbia that Terry White shared yesterday program about.
Okay, the hydrogen flows through from the tank into the engines, and that tank, when it gets loaded, is a minus 423 degrees. So between the cold temperatures and that temperature of that line, it worked over, and that's how they cold soaked the O-rings to probably to 8 degrees Fahrenheit.
Wow,
So,
brittle.
Yeah, they were not pliable. I won't say they're brittle, but again, that was where the failure was, and we go through the actual launch.
Well, in the Rogers Commission investigation, the physicist Richard Feynman showed how brittle they were by sticking a piece of it in ice water and then smashing it with a hammer, and kind of got the point across there to the congressman that this was not acceptable.
Okay, yes, that's true. Now, at T0, there was. Let's move on to the.
You want to show that or the
next one? At T0, they noticed after reviewing the films that there was a black cloud of smoke that came out of that joint. Now, but eventually, at T plus 3 seconds into the launch, that went away. And what they theorize is that the aluminum oxide and the char from the solid rocket motors firing actually plugged the gap back close. And there was no issues at that time. Now, at T plus 37 seconds and at T plus 58 seconds, then the shuttle encountered a very heavy turbulence, highest turbulence they had seen up to that date. And because of that, and this is right when they're ready to throttle down, the solid rocket motors can be gimbaled. The engine bells can be gimbaled. So they gimbaled very violently to keep the shuttle on track. And with that, and plus the throttling up, caused that gap to reopen again. And so then we had the burn through, and it burned through the attach point that was attaching the solid rocket motor to the tank. And the solid rocket motor actually came over and hit the tank and ruptured it. And that's what caused the explosion.
Incredibly, like a blowtorch cutting a piece of metal is what it did.
Yeah.
And then there was no, Challenger did not explode. The external tank exploded. Challenger crashed into the external tank.
Yeah, and the explosion ripped it apart.
Yeah.
And it broke the crew compartment apart. That happened at 48,000 feet is when it came apart. Due to the momentum, the crew compartment kept going up. It went to a height of 65,000 feet.
Another 20,000 feet.
Before it started to plunge back down to Earth. And it came down at, let's see here, 25 seconds after breakup, it hit the water at almost 207 miles an hour. And the crew was subjected to 200 Gs.
Yeah.
And that's not a survivable situation.
Absolutely not. You can read many, many things, books, articles, and so forth about this. Horrible. But most experts think that they had passed out, though they may have been alive. The lack of oxygen would have made them.
They do know they found 4 of the perks, what they call them, the personal egress air packs that were on their right behind them. There has a switch that turns them on. If they had lost cabin pressure, they would turn that on and it would give them oxygen to breathe. Do that. Normally the crew behind them flips the switch in front of the guy in front of them.
Mm-hmm.
Out of the 4, they found 3 that had been actually actuated.
Okay.
Speak up. Okay.
Well, Gary, you're doing a good job. It's a difficult subject to talk
Yeah.
about for sure. You were there, and we don't make any light of that. It's, all of these tragedies are very heavy in the hearts of everybody who was there, including Marty in this room. We've got Dan McCune, our crane operator here that runs our building maintenance. Dan's in the watching today. With fascination, I see Dan, and we'll have you on the show again. But no, it's hard to talk about, really. I find it hard because there's so much has been said about it. And, you have to leave some of it alone.
Well,
But this is a perspective, I think, that is very good and giving us a perspective of you being there.
it was, I actually was standing outside of the VAB. I had started in my office, and then Selena Score came by. She was a secretary that I had in the Apollo program, and she wanted to see the launch. I always bring my binoculars in just in case for a launch. And so we went together. We went out into the parking lot to watch the launch. And it's good to be out in the VAB area, but it's also bad. You get the impact of the sound waves coming off and hitting you. You get the roar of the engines. But as far as visibility, it's terrible. You'll see the shuttle as it goes up for a little bit until it does this roll. And after its roll, it pitches over. And then from now on until it gets way down range, you're looking exactly up the exhaust system. And so I had my binoculars. I was looking at that. And the first thing that I noticed is all of a sudden there was a spike of smoke coming off to the side, out the side. And I couldn't quite figure out what it was. I didn't know. I said, what the heck is this? So I dropped my binoculars, and then I saw the other one further out. That was the right-hand one that went further. And never heard the explosion. Just saw that it had gone, and I looked at Selena. She looked at me, and we just walked back. Didn't say a word. And I remember sitting in the office, and Horace Lambert was the director of shuttle engineering. Very, very talented engineer and very smart. He'd come zipping through, walking at a very high pace. He didn't go to his office. He kept walking down towards other engineering offices, and he kept saying, I know what it was. I know what it was. But I really don't think he really knew at the time. I don't think anybody knew until we looked at the videos and saw the puff of smoke. But I always wanted to ask him what he really thought, but I never had the chance to do that. And basically, it's been probably 7 years, 10 years that I can actually see the video.
Oh, wow. 38 years ago. And it's hard, Gary. I know it's hard. It's you're doing a good job. Let's wrap this up here a little bit with some of the fixes here. And though, this was a problem and it shifted to the tiles, but we had, successful missions, built a space station. But this is the actual joint that failed.
This is the joint. This is where it burned through. They did recover that off the ocean floor, and that's where they noticed it. Unfortunately, that's the result. Like I said, it burned through the ET attach point to the SRB rocket.
Now, when the SRB separated, like you're talking about, there's two contrails. One headed to Jacksonville and one headed to Miami. And ground range blew them up.
I don't think I even saw that.
Yeah, okay.
By that time, we were heading back.
Yeah.
What people may not realize is when the SRBs are ignited, and for the first 200 and something seconds, there's nothing that the astronauts can do to survive if they have a problem. They have to wait till they're ejected before any options become available. If they can get enough height and speed, then they'll return back and land at Kennedy. It's a very difficult maneuver to do. They're not sure that they would ever be able to do that. Unfortunately, we never had to. If the higher they got, the TAL sites became more of an option for them.
Transoceanic abort landing sites. And our friend Dean Schaff was over there.
There's two of them, depending which way they're going to launch. If they're 28 degrees, they go one way. If they're going to like the space station, then they fly up into, I think, into Spain. They would land in Spain someplace.
Those sites were never used either, of course.
No, they prepared for it. In fact, I had my passport and all my shots, and if it had landed there, I would have been part of the crew that had gone out.
To bring her back there.
Yeah.
Well, there was a fix. It took a while to figure out, 18 months downtime.
There were two investigations. The first one was the Rogers Commission, which was put in motion by President Reagan. And they studied it, and then at the end of 4 months of interviewing and studying and talking to engineers and everybody that was involved, they released a report that was 5 volumes long. And then after that was completed, Congress and their Committee for Space and Science Technology also did a study, a commission study. And that was, I forget who the chair was, but Bill Nelson was on that. And it was mostly congressmen. But it's a 450-page document. And I looked more at that because they summarize it a lot easier without going through a lot of, 5 volumes of all this. You get a lot of just static in there that, it's important, but it's not something you want to talk about on a subject like this. So I looked at the 450, and they pretty much agreed with everything that, because they had studied that report first, and then they did their interviews and studied the hardware, and they came to basically the same conclusion that the Rogers Commission came. They did have a little bit different take of what the final finding was, and I'm going to read it because it's a little bit long.
Sure.
The committee feels that the underlying problem which led to the Challenger accident was not due to poor communications or adequate procedures as implied by the Rogers Commission conclusion. Rather, it was the fundamental problem with poor technical decision making over a period of several years by top NASA and contractor personnel who failed to act decisively to solve the increasingly serious anomalies in the solid rocket booster joints. And that's really probably hits the nail on the head more than what the Rogers Commission came out. It was more politically correct, the Rogers was, than what Congress came up with.
Human error.
Human error.
Not using practical sense.
Well, it wasn't that. It was the pardon, I said the Thrycol engineers back in Utah recognized that the temperatures was a problem. But whenever they had discussions with headquarters or something, they would say, we have a problem with, we believe, with cold temperatures with the seals, and that's what we're seeing. However, nobody identified what is the cold temperature that you can launch at. They didn't do that. They just kept saying, we have it. And Thrycol tried to form a team to solve that problem, but they didn't get enough support from Marshall or from in-house, and those were all drops. So there was no actually, other than we were going to manage the program by Marshall, there was nothing else done to it until after the accident itself.
My. Yeah. Well, we're coming here to the end of this wonderful program that only you can do, Gary. You're looking at your notes there. We know Cynthia Rossi's enjoyed this, and Dave Stange and Doug Forrest. We got Mark and Tommy Usiak watching it. Gary Gerald, thank you all. Robert Law joined us from Dundee, Scotland, enjoying his evening hot toddy probably. Steve Jokums is in Illinois. Bill Whiting, Tom Celentano, Larry Pushkar. Good to see you watching, Larry. Carlton Bailey is at his hacienda in Canaveral Groves, and C.B. Spock has joined us today. So thank you all very much for spending your hour or so with us on Stay Curious, hearing Gary Allgire tell it like it is from a structural engineering standpoint there. Quickly, Gary, there's the before joint and then the after fix of it there. That's a little technical for much of us to understand. But
let's go back to the first one.
There you go.
I mean, we need to kind of really address
Absolutely,
this.
Sure.
There's a tang and then there's a clevis. The tang that you see, and I've highlighted some of the key parts. This is the original design. You can see the two O-rings, the black dots that are on the inner wall of the tang. And then the crosshair is the oxide, aluminum oxide putty that they would put in there that would supposedly preclude any hot gases getting into the seals. That material was inadequate. And so what happened on Challenger is the primary seal, which is the upper one, was compromised, and the secondary seal let go, and then they bypassed, and it started the burn through.
Can you point that out, Marty? You see the black squares there in the middle that might not, that's the actual O-ring. You're not seeing, you're just seeing a cross section. There you go, buddy. Thank you very much.
Now, in between the two O-rings, there's a port that they could pressurize to make sure that the seals were seated. All right. And then down below that is a pin that's looks like a rectangular box. It's actually a pin. Come down further right, come back up, and then to the right. Come back up. There you go. Those are pins. They go around the circumference of the joint, and that's what ties the two joints together. They have a clevis that comes in there and captures it so it cannot fall out. And they had issues with the O-rings, again, having blow by. The putty itself, they had issues with it. When they did the pressurization check, sometimes they would pop a hole into that material, and that would allow for something to get through. So that was the issue that we had for all those years with the O-rings.
24 successful launches with problems.
All the joints had the same type of system. After 2 years, this is what we ended up with. We ended up adding a third O-ring. We
They're
changed.
blue on that
They're blue.
diagram, Marty, if you could point
Yeah.
that out,
The
please, sir.
the tang was redesigned so that
Yeah, there's no.
keep going right there. There's three of them.
The two ovals there.
There's two ovals.
Yeah.
There's three ovals. One more pull to the right just a little bit. There's
Yep.
the third one. That's an added safety device. Now they also what they did is they call it a latch that they extend beyond the O-ring, and the theory is that will keep the O-ring from being pushed out when they do the pressure checks on the O-rings. They added a second pressure port. The first one, or the top one, verifies the seal between that seal and a seal that's on the other side of that tank of the clevis. And then the bottom one checks the pressure between the two O-rings to make sure they have an adequate seal. They did away with the putty that was used and used for cork. And you'll see a thing called the J seal.
Mm-hmm.
And what that was intended to do is when the exhaust would penetrate it, and they would expand that joint, and that pressure of the upper half pushing against the clevis, but also help hold the O-ring together. And then they had a heat sensor. They had temperature gauges on that they could look at to see what the temperature was of the O-rings before launch.
Wow. Oh, really?
And then
Okay.
they added more insulation on the exterior to keep rain from coming in, because on Challenger they did have when they were setting the SRB rockets, when they were staging it before they came into the building, they were under a cover, and we had a big rain, and one of them that segment did get exposed to rain, and it got into the seal. So they replaced that, and then they replaced the matching side of the other side, so they have matching pairs out of that same casting.
Very interesting.
And then-
Very interesting, Gary. Yes, sir. Continue there. Yeah.
Okay. After this was fixed, we never had another issue with O-rings falling,
Uh-huh.
burn up issues at all.
Oh, really?
Yeah.
So this was a good fix.
This was good. This is the fix they should have had at the very, very beginning.
Huh. Add an
they-
extra O-ring,
Yeah.
more protection, and temperature sensors.
And another reason why nothing was done, they were going to use manage the system, is that I was told when we found out the problem, they knew that it was going to take 2 years of redesigning to do it, and that would shut the program down for 2 years. Congress at that time was not favorably in favor of the space shuttle, and the feeling was if we shut down for 2 years, they would cancel the program.
Yeah.
So we marched on with a crutch. Again, Marshall was responsible for managing that. I don't think I can say that they did an excellent job. They did a poor job, really, covering and not making it. What bothered me is I couldn't understand why we still launched when we had the ICE team and we had Rockwell under Patron saying we should not launch. Why did we launch?
And Morton Thiokol executives actually flew back to Utah
Yes.
because they didn't want to see it.
They didn't want to see it, and the engineer that brought us to an issue, he was asked to sign a document that says that we could launch and it would work, and there would be no problem launching it. And he refused to sign that piece of paper because he was not comfortable with that, and then ended up his manager above him signed it instead. But the question was, why did we still launch that day? And one of the reasons that we heard, which is President Reagan was going to do his address to Congress that night.
State of the Union address.
State of the Union address, and he was going to announce in that State of the Union address that Christy McCullough was up in space as a teacher, and she was going to teach it.
They're going to try to talk to them
Yeah,
directly
that's right,
during
yeah.
the pass, I think.
Yeah. But I think that's a little bit weak because they could always change his speech to accommodate what was going on. If we had scrubbed on that day, then he would have just said, well, she's here at the Cape, ready to prepare to launch. But the other issue or reason that was brought out, and it was brought out by the same engineer that wouldn't sign that document, is Christy McCullough's class, her lesson she was going to teach was on day 4 of the mission. Now, launch was day 1, and which was a Tuesday. So day 4 was a Friday. So if they waited till Wednesday or Thursday to launch for weather or whatever, she would have had the lessons plans on Saturday or Sunday. So I think that was the real initiative to launch her into space. And the launch team never had any indication that those concerns by the cycle people were there. It was not. They were clueless really to that.
Wow.
So you can't blame them
keep saying
because they didn't know.
Hmm.
So it's in a part of the shoe. They did not, Marshall. They did not bring it up. They knew, but they didn't bring it up. They knew that the engineers were unhappy with it, and so they just didn't bring it.
It was Reagan's baby, the teacher in space program, and Krista McCullough. Thousands of teachers applied. She and Barbara Morgan were on the top of the heap, and it wasn't just it was a program to see thousands of kids were going to participate in it in the country. They were all going to be in 1986. This is a big event to have a TV from space teaching with a teacher in space. This was way outside the box.
Eventually, they did do that. The backup.
Barbara Morgan did.
She did her
12 years later, or something like that.
She did the class for her.
But she did do the class. So,
but it's just very, very unfortunate, and you wish you could get it all back. And especially for me, because if it had the battery, if it had not died, maybe it had launched.
Yeah,
Challenger would have never happened.
If they had taken your advice and taken 2 batteries up there, that's
it's not better. The drills back then.
Drills, yeah.
The drills had the batteries built into them.
Right.
We didn't have the detachable batteries.
Well, maybe you needed an outlet up there with a cord drill to plug it up there.
Rockwell was never good about their GSC as far as that was a big problem in Apollo. When we get on station and we would pull out something, it was either they have inspection requirements. They have to be inspected recalibrated every so many days. We always got something that was out of calibration, and then we couldn't do the job. So,
well, we appreciate your candor. What a great program. We've learned through Marty that Wiltech is the company, is the building on the left.
Dan.
Okay.
The what?
Dan said that.
Oh, Dan figured that out. Wiltech. What's Wiltech?
That's a shuttle component cleaning facility.
Shuttle component cleaning facility on the left, and the non-destruct lab above my head there. What are they non-destructing there?
They would check all the welds.
Oh, okay. On there. So put 2 important little facilities there. We need some space workers from them to come and help you stay curious on there. Gary, what a fabulous job you've done on 2. He's actually done 3 programs in 2 weeks here. Last week's the successful failure of Apollo 6 is quite an incredible story that the next Saturn V took us to the moon with a few anomalies, by the way. Marty, question and comment?
We have a question from Larry Puskar. 6 months before the accident, I had breakfast at the Cape with my friend who felt the government was pushing them way too hard and said we are going to have an accident. Gary, did you feel any pressure like that?
That was a prevalent theme that people put out. There's times when the launch directors would say we're going to launch even though the weather was predicted to be 90% bad. And if you asked them, they said, well, we're going to shoot for that 10%. And if we make it, we make it. It'll look good. If we don't, we just reschedule. And those things happened, it could be on the weekend, and you thought maybe you were going to get off, and then they decided to go ahead and launch. That was really the only pushing that I really saw. Schedules are impacted by training of the crew, how well the hardware treats us. If the payload people have an issue, that will delay the launch. The space shuttle itself may have an issue that will delay the launch. Weather can delay the launch. And so you try to accommodate the closest you can get to that actual launch stage that the customer signed up way back several years before that. This will be your launch date. So you try to maintain that. And the Rogers Commission noticed also, actually so did the Congress's Commission, that because of the limited training facilities for the astronauts, that they were going to run into a problem where they couldn't train because everybody was trying to use the trainers at the same time because their missions stacked up. So, I went into NASA knowing that I'd be working a lot of hours, and that was just part of the deal. I missed a lot of funerals, family birthdays that I couldn't go to because we were getting ready to do a launch or something like that, and you had to support it. And that was just the way it was. When they said you will work, like I worked third shift, and then turned right around and came in on second shift. That's something that I knew I had to do, and I did it.
Mm-hmm.
And the only one time that we ever affected the operations people was back in STS-6 when we talked about that first IUS.
Yeah.
And Titusville we were going to put in. Schedulers had scheduled. It says that you're going to take it out of the canister, put it in the back of the room, and then roll up to the orbiter, and you're going to put it in immediately. They allowed 8 hours between taking it out, putting it in the back of the room, and then putting it in the orbiter. This took about 10 hours each time to do it. So the technicians were overworked. They never complained, but they worked long hours. They were given 8 hours rest. And you cannot stop work, go down through the elevators out to the parking lot, grab a ride back to wherever your car is parked, go in your office, undo what you had to do, and get back in that car and go home, and then meet the family, take care of whatever issues they have in 8 hours, and come back out and repeat that. So we forced, between myself and my Rockville counterpart, we told NASA operations, you will not do that again, because we had technicians that worked so long, they made a mistake, and that caused us to almost drop the IUS into Payload Bay. And if we had dropped it, would go all the way through. And solid rocket motors, we've been told the grain, you can't light it with a cigarette lighter. You cannot light it with a match. But when they hit that impact, the shock load of the sudden stop will cause the grain to shear, and that shearing force will generate enough heat to set off the engine. So what we would have done is it not only dropped it, we would have destroyed the pad and the shuttle and anybody that was out there that day.
Wow.
So
that's a story to tell again.
So
when another future Stay Curious.
And so when we went to the operations people, we demanded, says, you will never do this again with an 8-hour rest period. We will have a 24-hour rest period. They grudgingly agreed, and then when I went into operations, they reminded me. He says, we've never let engineers dictate our schedule.
Oh, well, listen to you, Gary. All right.
So I said, no, well, I did it because I looked out for the safety of our techs and our people. I said,
and a $2 billion investment by our taxpayers,
yes,
and all that pad around it, of course. Gary,
yeah,
phenomenal story from the one and only Gary Allgire here, our friend at the American Space Museum. Come on a Tuesday or Thursday if you're going to visit it, and this guy will give you a tour like you've never had one before. Marty, a comment or question?
Yeah, I guess it's a question from Dan McHugh behind me. Dan mentioned that they had heaters installed on the segments.
they did after I was part of the fix. They did put heaters on there so they could maintain the temperature. But prior to that, they did not have heaters on them.
What amazing technology. You see it evolves. I'm so happy to hear that the SRBs never had the issues that they did the first 25 launches. Of course, we're using the same concept on Artemis 5 stacks instead of 4. So, and that was actually the idea for the Constellation, was to have a solid fuel rockets with the Ares rocket there. So we've enjoyed talking to you, Gary. It's an emotional thing for you and everybody in this room, except for me that lived it. We wanted to go out on kind of a high note to celebrate the Challenger Center. On their webpage, the Challenger Center is based in Washington, D.C. and has about over 30, I think almost 40 centers around the country. There's one in Tallahassee here in Florida. In the aftermath of the Challenger STS-51 tragedy, the crew's families came together to firmly commit themselves to carrying the spirit of their loved ones by continuing their education mission. In April '86, just months after the tragedy, the Challenger Center for Space Science was created by the families of the Challenger crew. The family's visions was to create a place that would inspire children, where students could conduct experiments, collaborate to solve problems, and immerse themselves in space-like surroundings. Their goal was to spark an interest and joy in STEAM education, a spark that would change the trajectory of children's futures. To date, the Challenger Center has reached more than 6 million students around the globe and continues to inspire hundreds of thousands of students every year. So, in a horrible tragedy, we have found a silver lining with some of these Challenger Center people 30 years ago have become space workers. I'm not sure any of them have gone to space, but that's a time for another story.
2.
So, 2?
Well, one has for sure. One was one to.
And who's that?
It was Frank Cadero.
Cadero from
Yeah.
Brooklyn.
No, he was from Argentina. He was in our office, and he was selected along with Lisa Norrock,
Yeah.
and she was the other one selected. Now she did fly, but Frank died before he was able
Okay.
to fly.
All right.
So
from the Challenger Center.
JSC allowed 2 people from here at Kennedy Space Center to become astronauts.
Awesome. Well, Gary, thank you so much for taking your time, and you all taking your time out
Yeah.
there to enjoy this great program, buddy.
Kinda
Appreciate you there. Your brain is now is emptied from
well,
these
yeah.
things, but seriously,
think about it.
I realize the difficulty you to be researching some of this stuff, and I'm sure there's a few moments the last couple of weeks that you had to grab a handkerchief maybe or catch yourself.
Well,
I give verklempt all the time thinking about this, folks, and hair raises on my arms, and it's just from talking to Gary and Marty and good Dan McCune here watching today. They lived it. They knew these humans that were going to space, and they were the humans here, Earthlings, that helped them do it. So
Yeah.
tomorrow we're going to have any final thoughts, sir?
No, I just that I think that one of the things that a learning lesson is if you're an engineer or a technician, and especially if you're in a meeting and you know something that and the other managers are on a different wavelength, speak up. Don't sit there and say nothing, because if you say nothing, theoretically you're agreeing to whatever they think that they have solved, and if they're wrong, speak up. It doesn't hurt. I mean, it's better to be wrong and if it works, but if you had not said anything and it failed, then you'll always regret that.
Good words of advice, parting shot there from Gary Allgire. Tomorrow we have a wonderful program with launch director Mike Leinbach, who launched the STS-107 astronauts to space, and tragically they did not come home. Mike will take your questions. I will put a Facebook post up there where you could put some questions to Mike. We've got some questions already come in from Marty and some of us around here. We're going to have a wonderful time with a great guy. Mike Leinbach will be here in our studio to talk about anything you want to talk about. And Columbia's fair game, Artemis's fair game. He is the man that recommended Charlie Blackwell Thompson to be the launch director for Artemis. And have you ever been around Mike much, Leinbach?
Not a whole lot.
Okay.
Not really. Not the launch directors. Very, very, very seldom that we would interface with them.
Well, I have on personal events around town and so forth like that, and what a great guy, and he wants to help our museum just like you do. So if you have financial ways to help us, go to our website and there's a button to donate up there. So, Gary, again, thank you very much for a wonderful
Okay.
program. Marty, Streamlabs was flawless again today, and we're all excited to again do another wonderful conversation this week with Mike Lineback. I'm Mark Marquette saying, come and enjoy that conversation and bring your question to Mike Lineback tomorrow, all to bridge the space between us. Thank you for watching.